Okay, so T4 is just derivatives and derivatives. What's the first one? Use the definition of the slope of the tangent line, and only that definition, to find the slope of the tangent line of the function blah. Show all your work. Oh, I got something stuck in my throat. Anyways, the limit definition I provided here. As with all the questions, you can find the definitions. So if you ever want to look back on it, they'll just be on the right side. But yeah, so for the limit definition, we're just going to use this. The limit as h approaches 0 for fx plus h minus f at x over h. Once again, since we're dealing with f of some input, we're going to do where all the x's are, we're going to plug this in, right? So we have 8x squared, that's going to be 8 bracket x plus h squared, because this is the input. Similarly, minus f at x, well, that's just x is the input, so x is x, and then over h squared. So since we're dealing with 8x squared plus 3x plus 4, that's going to go to 8 bracket x plus h squared plus 3 bracket x plus h plus 4 minus the original function over h. Right, so then we can just say that is equal to, well, we're going to want to expand the x plus h squared, and I guess I can just write that out really quickly. Yeah, okay. I just had to change the pen settings. Right, so this is just x plus h, x squared plus 2xh, right? Because we have x goes to x, and then x goes to h, and then h goes to x, h goes to h. So that means we have two xh's and plus h squared. So that's what I did here, and then I multiplied the 8 into it, and I rearranged all the pieces. So we have 2xh with respect to 8, that goes to 16xh. And I suppose I can show the cancellations here. That cancels, that cancels. That cancels, that cancels, and that cancels, that cancels. So a pattern you'll notice is that you're going to want the original piece over here on the right. This is going to cancel with some piece on the left. If that doesn't happen, you're going to have a problem, because then you're not going to be able to get rid of the h on the top by factoring. Right. So that should be the case for just basic like polynomials. Right, so we're left with this piece here. So we're just going to rewrite it down here. Lim h goes to 0. 8h squared plus 16xh plus 3h over h. Since we do not want to have something over 0, right? We do not want this. We're going to factor out an h so that they can cancel on the top and the bottom. Like this. And then we're going to be left with just the top. And since we have h goes to 0, we can just put 0 in for 8h. Right? So that's going to go plus 0. That leaves us with 16x plus 3. You can plug in x equals 3 to begin with if you want. You do not have to do it the way that I did it. I prefer to do it this way, and then I like to sub in the value after I've done this, but you can originally sub in 3 if you want. That's not a problem. Right, so we just have f prime 3 equals 16 times 3 plus 3 is 51. So that is the slope of the tangent line to this function at x equals 3. I must be sick or something. Okay, use the definition of the derivative to determine the derivative, so the general form. Here we're not finding the exact slope. So show all your work. So in the case where we have a rational, once again, wherever we have an x, we're going to do x plus h for the left side, right? Minus the original function. And in this case, in order to add two things that are of a different denominator, right? So if x plus this, we're going to want them cross multiply, so that's just going to be 5 times b plus 5 times a over a times b. So in this case, we're going to do x plus h plus 4 times negative 5 over here, and x plus 4 times 5 over here, right? So we're going to cross. Just like this. Now we have 5x plus 20 minus 5x minus 5h minus 20. And once again, as we saw with the previous question as well, we have the original pieces. With respect to the multiples of the bottom, those are going to cancel out, which is very nice. Leaving us with just minus 5h on the top. We have h on the bottom, so once again, we can just cancel those out. And we're left with something that we can sub 0 into, where we're not going to get like a over 0. So we do that, and then we're just left with the function here, right? Okay. So what is this one? Yes, the derivative rule. So the first one we're going to look at is the power rule. Basically what that is just that we have, a x to the n the next step of the derivative, then say this is f at x. The first derivative is just going to be equal to a times the degree up here to the x n minus 1. And if you wanted to carry this on, we can say the double derivative is therefore just a times that times the top ones again, x to the n minus 1 minus 1. And then you're just going to do dot, 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 so on. So in this case, we just have x to the 6. Well, following this rule, we're just going to bring the 6 down. Then we do x to the 6 minus 1, so it goes 6x to the 5. Here I have 8 over x to the 3. Bring that up, right? So you can do that since it's over. That's just going to be equal to this. And then you're going to do the same thing again. You're going to bring this down. 8 times negative 3 to the x minus 3 minus 1. It's going to go to negative 4. And so since you can bring it up, you can also bring it down. So it's just negative 24 over x to the 4. Here, if you have a root, you can just rewrite it in terms of the power, right? So if you have like root ab, that's just going to be equal to x to the b over a. So do that. Once again, bring the top down. Subtract the top by the minus 1, and then you can rewrite it back in its original form, which is going to be 11 minus 4. Was it 11 minus 4? Yeah, over 4. It's just 7 over 4. And so we can reverse that process to get fourth root to x to the 7. Once again, we're using the power rule here, except this time we're doing it for an entire function. Previously, we just did it for singular pieces, but yes, you can distribute like a derivative out through an entire function. So it's just the same thing as we did before. Right? We're going to rewrite it in a form that's easier to look at. So the third root x squared, that's going to go to 2 over 3. 3 over x squared is going to go to 3x to the negative 2. And then plus 1 is just plus 1. Right, so bring the top down. That's going to go down here. Multiply by 4, that goes to 20. This is 2 over 3, so we'll bring 2 over 3 down. This is going to be 2 over 3 minus 1. Right, so it's going to be negative 1 over 3. So we can bring that down to here. Plus 3x to the negative 2. So you can bring the negative 2 down. That gives us negative 6 over x to the 3. And the plus 1 is just going to go to 0. Right, because that's effectively just 1x to the 0 minus 1, and then 0 times that entire thing, because we bring the 0 down. So for b, yeah, once again, just bring the 3 down. That's 3 times 2, 6x squared. And then we have 6x squared, which is plus 12x. Okay. This is the first introduction of chain rule. So with the chain rule over here on the right, basically what it is, if we have a function inside of another function, right, we can say that this is a function inside of x5, right? So you can imagine this is like x5, and then this is like some function f of x, or just like this, right? So for chain rule, basically what we're going to do, we're going to take the degree down as we always did, so the 5 goes down. Multiply that by the derivative of the inside, and then multiply it by the original to the power minus 1, right? So we have 5x to the cubed plus 2x squared plus 7x plus 4. All this to the 5. Well, we're going to bring the 5 down. That goes to here. The derivative of the inside is going to do the power rule once again. So we have 5x cubed. That's going to go to 15x squared. 2x squared is going to go to 4x. 7x is going to 7. And the final piece that we want is we want times the original 1 minus the power minus 1. So just rewrite this piece over here, and then just take like a minus 1 off the top. So that's it for that. Once again, we can rewrite the reciprocal. Right? We can bring the power up, the rational. So we just have 5 bracket 4x cubed plus 7x squared plus 3x plus 1 to the negative 4. So the derivative of this, we're going to do the chain rule again. Right, so we're just going to bring this down. Negative 4 goes to the front. 5 times negative 4, that's negative 20. Times the derivative of the inside of this, 4x cubed. 3 goes down, 12x squared. Plus 7x squared is going to go to 14x. And that plus 3x is going to go to plus 3. All over the original minus 1, so that's negative 4 minus 1. And we see that goes down to 5. Yeah, my voice is really off today. I apologize. And geez, I don't know what's going on. Oh, this is a monster. Find the derivative of the following functions. Oh, it's a chain rule and a product rule. Yeah, that's terrible. So for the product rule, if we have a function listed in this order where we have f at x times g of x, will the derivative of this, I wrote down on the bottom right, I believe, yes. It's just the first one, the derivative of the first one times the second one, plus the first one times the derivative of the second one. Since we are dealing with essentially just f at x inside of some degree n, we're going to use the chain rule again. The chain rule is just going to be bring n down, times this by the derivative of the inside, and then just rewrite this as, you know, the original minus 1. Okay, so we do that here. So for 4x to the 4 plus 3x squared to the 7, bring the 7 down, take the derivative of the inside, 16x cubed plus 6x, times the original, just rewrite this, to the 7 minus 1, that's 6, times the second function. So here I can write this out. This is f prime of x. This is g of x. This is just f at x. And then this is g prime of x. Plus f at x times g of prime of x, which is 3x cubed plus x plus 7 to the 4. 4 goes down here. We have the original minus 1, 3, and the derivative of the inside, 9x squared plus 1. Yeah, these can get really long. Jeez. Okay, what's b? Yes, b is much nicer. This is the first introduction to the quotient rule. Right, so we have the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Right. So in this case we have 4x squared plus x plus 1 is the top. The derivative of this, using the power rule previously, 8x plus 1 minus times the bottom, right? Minus the top, so we just rewrite it, times the derivative of the bottom, it's the power rule again, 7x squared goes to 14x, plus x, that goes to 1, over the bottom squared. 7x squared plus x plus 3, and that's squared. Right. I will probably come up with like practice questions for these because whilst you're given the rule, there can be tricky ones. So I'll see if I can like come up with like practice problems. Alright, anyways, what's the last one here? Find the equation of the tangent line of the function f at x equals square root x to the 4 plus 4x squared plus 1 at x equals 1. So in the case where we want to find the tangent line, we basically just want to find the linear function, right? That's just y equals mx plus b. Alternatively, you can also use the form y equals m x minus x1 plus y1. That's what I did here as well. Because essentially the tangent's just where it barely touches at some point. So we can imagine we have like, you know, some quadratic function like this. This is x equals 1. And we want to find the slope such that it just goes like that. So yeah, in this case, since we're dealing with the tangent line, right, we're going to want the slope, which is just the velocity at some point. So to find the velocity, we can find the rate of change at that point, which is the derivative. So the first thing we want to do is we want to take the derivative. Since here we're dealing with the chain rule, right? We have this function again inside of another function here. F of x, and then we have a half. So in this case, we're going to bring the half down times the derivative of the inside. So x to the 4 goes to 4x cubed. 4x squared goes to 8x. And then over, we have the original 1 over 2 times the original minus 1. Well, that's a half minus 1. That's going to go to negative a half. So we write it on the bottom as a square root. Now that we found the derivative of the function, we're going to want to find it at x equals 1 to find the slope at that point. So f prime of 1 is equal to, just put 1 into this function here, 4 times 1 plus 8 times 1, 12, over 2 root 1 plus 4 times 1 plus 1, 6. So 12 and 2, we can go to 6. And then 6 over the square root of 6 equals square root of 6. So therefore, we have the slope at that point is going to just be equal to the square root of 6. Right, so now using y equals m bracket x minus x1 plus y1, right, we can just find that point. We have x1, y1 equals 1 square root 6. So therefore we can put all of this into this function over here to find the tangent of the line, basically. And I believe that is it.